Hi guys, welcome to this page of the notes. Let's go ahead and take a look at our last type of variation function here. It's going to be combined variation. Here's the reason it's called combined variation. You can read it right there, combined variation. What I have is I have y varies directly, right? We've already looked at direct variation. That was our first type of variation. Y varies directly as x. I know what that looks like. Let me slide up here just a smidge and you'll see that this one, y varies directly as x, means that y is equal to k times x, right? Then I tell you, let's see, y varies directly as x and inversely as z. That means y varies inversely as z. Well, that was our third type of variation function. We know what that looks like. Inverse variation is y equals k over z. Right? And what I'm doing is I want to put these two guys together, right? I want to combine these two types of variation. I want to combine direct variation. I'm sorry, I want to do that in a different color. Hold up. Let me do yellow. And inversely as z, which means y is equal to k over z. There we go. So I want to put these two types of variation together. Here's kind of the way you can think about it, right? Y and y. That's the same. That doesn't change. K and k, same variable, plus we know it's a constant, it doesn't change. The only difference here is I'm multiplying k by x in this one, and in this one I'm dividing k by z. So if I were to go ahead and put those two things together, what I would wind up with is y, because right, I have a y and a y, it's the same variable, it doesn't change, same thing. And the k, right, k doesn't change, it's a constant, so y equals k. But in this one, k is multiplied by x, so k times x. However, in this one, k is divided by z, so divide by z. And what you've got right here is our combined variation formula. Y equals k times x, that's the direct variation. Y varies directly as x, y equals k times x. And y varies inversely as z. Y equals k over z. That's the inverse part. We put those two things together. Y equals kx divided by z. Combined variation. You're taking direct variation, inverse variation, you're putting them together, and you wind up with this combined variation formula. But again, we probably won't use it that often. You'll almost always be given an initial and a final set of conditions. So, just like we've seen in the three previous types of variation, here's my initial y1, x1, z1. Here's my final y2, x2, z2, right? K is a constant. It's the same. Doesn't matter what the value of x, y, or z are. This constant has to be the same for a particular set of conditions. And so we can go ahead and set those two guys equal to each other. And this is the one I think we'll probably wind up using the most. y1 times z1 over x1 equals y2 times z2 over x2. Again, please notice, right, I have to multiply by z, divide by x in order to solve for k, right? So that's why that x and z, they've kind of switched places, right? I'm trying to solve for k. And in order to do that, I'm dividing by z, so I got to multiply the z to the other side. There it is, y1 times z1. And I'm multiplying back, so I got to divide that x to the other side. So I know in this, z's now on the top and x is in the bottom, but that's because I've solved for k. So they switch places when you solve for k. All right, so here we go. Let's jump into it. We'll show you a couple of times. I think you'll catch on real quick. They're not that bad. Here's what I'm told. I'm told f varies directly as g and f varies inversely as h. So there we go. I know that I have combined variation directly and inversely. Here's what I'm told. F varies directly as g. That means that I have f is equal to k times g, right? That's the direct variation. F equals k, that's my constant variation, and g because it's directly as g. But then I'm told f varies inversely as h. So f equals k. The inverse would be to divide by h. Put that whole thing over h. And then if I were to solve for k, multiply the h to the side, divide the g to the other side, I get k is equal to f times h over g. K equals f times h over g. I can do my initial and final set of conditions. So f1 h1 over g1 is equal to f2 times h2 over G2. And at this point, because I've got my initial and final set of conditions for F, H, and G, plug in what you've been given. Don't fat finger something on your calculator. Should be good to go. Again, this is the combined variation equation. Solve it for K. Initial set, final set, set them equal to each other. Away we go. So here we go. I want you to find G. Great, I know I'll be solving for G. When F is 18, H is -3. Again, remember, I generally like when I'm given all three variables, I like to make that at my initial set. So I know G is 24, H is 2, and F is 6. So I'll plug that stuff in here. F 6, H 2, G 24. So let's do that. I'll have 6 times 2 divided by 24. Okay, awesome. So that's taking G, H, and F, plugging that in for my initial set of conditions. Again, if you plug them in over here, you'll get the same answer that I do. I don't know. Weird, I just prefer to put them in for my initial. I'm going to be solving for G, so that G2 is what I'm going to solve for. I'm told F is 18 and H is -3. So I'll have 18 times a -3 all over G2. Okay, so here's what I did. Let's see, I wound up doing 6 times 2, which is 12. 12 divided by 24 should be 1/2. I think I did 18 times 3, -3, so -54. So here's what I wind up with. I know that 12 divided by 24 comes out to be 1/2. That's all equal. 18 times the -3 is the -54, so -54 over G2. Okay, I need to solve for G. So here's what I'm going to do. I'm going to multiply the G2 to the other side. And because I'm dividing by 2, I'll multiply the 2 to this side. So I wind up with G2. G2 times 1, which is just G2. Multiply the 2 to the other side, so that's all equal to -54 times 2. You guys should remember this from middle school as just cross multiplication. Cross multiplication, multiply the G2 over here, multiply the 2 over there. And you wind up with, again, don't fat finger something on your calculator. My calculator tells me -108. Hey, let's go ahead and try another one. Highlight this sucker. Suppose that P varies directly as R, inversely as T. Okay, I can definitely write that. P varies directly as R. Well, I know that's P equals K times R. But then I'm told that P varies inversely as T. That would be P equals K over T. So we'll just throw a T in the bottom there. Solve for K, multiply by T, divide by R. So K is equal to P times T over R. And then initial and final set. P1, T1, R1, P2, T2, R2. Fantastic. At this point, it'll be plug and chug. So here we go. Let's see. I'm told that P is -5. I can do that. -5. I'm told that T is 20. Wait. Yeah. T is 20. I apologize. Sorry. I need that. P is 4. If T is 20, P is 4, and R is 2. So replace that -5. My apologies. Replace that -5 with a 4. That was almost a disaster. Divided by R, which is 2. That's all equal to, here we go. I'm asked to solve for T when R is 10 and P is a -5. So that P -5 will go in over here. I'm asked to solve for T, so it's T2, and I'm told that R is 10. There we go. So I'll be solving for T2. Well, 4 times 20 should be 80. Divided by 2 is equal to -5 T2 over 10. 80 divided by 2 is 40 equals -5 T2 over 10. Multiply the 10 to the other side. 400 equals -5 times T2. T2 is equal to 400 divided by a negative 5. Again, don't fat finger something on your calculator. How about a minus? T2 should be a minus 80. Okay, guys, so that takes care of those two objectives, direct variation, joint variation, inverse variation, and now combined variation. And like you saw in all these example problems, I give you an initial set of conditions, a final set of conditions, and you are asked to solve what turns out to be a fairly simple algebra problem to solve for one of those variables. Head on over to the next page of notes and we'll look at how this concept in Algebra 2, this idea of this idea of variation functions applies to a particular science, in this case chemistry. I'm excited to show you, and I'll meet you guys there.